Hi students, now we are going to derive an expression for the moment of inertia of a uniform ring. So what do you mean by uniform ring? It's a mass per unit length at every point along its circumference is a constant. Okay, this ring is held in the horizontal plane. Okay, it is held in the horizontal plane. And the axis of rotation passes through the center of the circular ring, and it is perpendicular to the horizontal plane. So it is mentioned axis passing through its center and perpendicular to its plane surface. Okay. So now let us consider this is a ring whose radius is r and its circumference is 2 pi r. Now, as usual, we will find the moment of inertia of a small portion of the ring which is called an elementary mass or point mass. So, this entire ring is assumed to be made up of large number of small elements. So, one such element of the ring, is having a mass dm and its length is dx. So now let capital M be the total mass of the circular ring. So M is the mass of the circular ring, and the length of the ring, that is equal to 2 pi r, that is the circumference of the ring. Okay, what is the total length? So suppose if I will cut this circle and expand and keep it along a straight line, can you see here? It will be a straight line. So that what will be its length? Its length will be equal to what? 2 pi r. So I cut somewhere and I stretch this into a straight wire or rod, so that its length L will be equal to 2 pi r, that is equal to the circumference of the ring. Okay. Now this small element is having a mass dm. So dm is the mass of a small element, and its length of the small element is dx. Now, I said since it is a uniform ring, the mass divided by length at any portion of the ring will be constant. So that is a mass by length, m, total mass divided by the total length. This must be equal to the small mass of the element dm divided by its length dx. Mass divided by length. And this is now called as linear mass density. So linear mass density, and it is denoted by the symbol lambda. This is equal to lambda. Okay. So if I divide the total mass of the ring by its total length, that is circumference, it must be equal to the ratio of the elementary mass divided by the elementary length. So from this equation, I am going to express dm in terms of the other three factors. So from this equation now, what I am going to write? Dm. This dm is equal to capital M by L into dx. So this is the required equation number 1. I am expressing dm in terms of capital M. Okay. Then what is the opposition offered by this small element to the rotation of the ring? Suppose if it is rotating about an axis, each and every portion of the ring will oppose the rotational motion. That only is called as moment of inertia. So first I will find the opposition offered by this small element to its rotation. So moment of inertia of a small element, okay, of a small element of mass dm and length dx, that is denoted by the symbol di. Okay. So it is equal to the mass of the element into distance square. Okay, dm into x square. So this is step number 2. Therefore, mass, that is moment of inertia of the entire ring of the entire ring is given by I is equal to integral of di, that is equal to integral of dm into x square. Okay. So we have to add dm into x square for all the elements. Understand? Now what is here? X. X is the distance of each element from the axis of rotation. So one element is shown here. It is at what distance from the axis of rotation is r itself, is it not? So here what? X is equal to the radius of the ring. Like that, if you take another element here, okay, so this also will be at a distance r. So the other element, okay, here this is also at a distance r. So all the elements on the entire ring are at the same distance, that is equal to the radius of the circular ring. Therefore we can replace this x square by r square. So this is now equal to integral dm into r square. Okay. Now what are the limits of the integral we should mention? Isn't that the limits? So you see here, when I cut this circle, when I cut this circle and stretch this into a straight line, then the first element will be at x is equal to 0, at a distance 0. And the last element will be at a distance of 2 pi r, is it not? Because the length is equal to what? The circumference. So the first element is at a distance 0 and the last element is at a distance 2 pi r. So for all the elements we have to find dm into r square and add them. That is only called as integration. Now this is equation 3. So I is now equal to integral of dm into r square between the limits 0 to 2 pi r. Now in place of dm, what I am going to substitute is equation 1. Is it not? So dm is equal to m by l into dx I am going to substitute here. So now this is equal to integral m by l, okay, m by l into dx into r square, okay, between the limits 0 to 2 pi r. Now what is L actually? L is the total length of the ring, that is equal to what? The circumference. So in place of L, what can we substitute? 2 pi r, is it not? So this m by L becomes m divided by 2 pi r into this r square is constant into integral of dx from 0 to 2 pi r, integral of dx. So now this r square and r, okay, can be cancelled. So this r get cancelled, so that now I is equal to, okay, I is now equal to m into r by 2 pi. So this is m into r divided by 2 pi. Now integral of dx, integral of dx between the limits 0 to 2 pi r. So this is now equal to mr divided by 2 pi. Integral of dx is x between the limits 0 and 2 pi r. So the lower limit is 0, upper limit is 2 pi r. So the value of x while substituting, upper limit minus lower limit we have to substitute. So now this is equal to mr divided by 2 pi into 2 pi r is the upper limit of x and minus of lower limit is 0. So this is now equal to mr divided by 2 pi into 2 pi r. So 2 pi get cancelled. So mr into mr, this is mr square. Therefore the moment of inertia of the uniform ring about an axis passing through its center and perpendicular to the plane of the ring is found to be what? I is equal to mr square. Okay. So what I said first, we define a linear mass density. What is linear mass density? Mass per unit length. So if you divide the total mass by the total length, that must be equal to this elementary mass divided by the elementary length. That is the first step. Then I express dm in terms of m. After that, we start always with the same step only. Moment of inertia, one element you find out. Then you integrate between the limits x is equal to 0 to x is equal to 2 pi r or as per the given case. So that now we have integrated between the limits 0 to 2 pi r and we got I is equal to m r square. I hope you must have understood well. Fine.